Okay, good morning, everybody. So first of all, I'd like to thank the organizers of the Global One Health Symposium. This is the first inaugural symposium, and I'm pleased to have the opportunity to speak to you in this symposium. So what I'm going to talk about is the application of the One Health approach to plastic particles in the environment as one part of the topic, and also what are some of the misconceptions that have emerged? Why is it that the topic of plastics in the environment has become particularly susceptible to misconceptions, and why it's so important for us to be aware of this and to address this as part of our engagement with addressing the environmental science around plastic particles. So if we consider, first of all, is the One Health approach appropriate for managing plastic particles in the environment? Start with a recognition of what is the One Health approach. And so clearly here from the World Health Organization, from the European Commission, recognizes the One Health approach as an integrated, unifying approach that aims to sustainably balance and optimize the health of people, animals, and ecosystems. And if we consider the use of the One Health approach, and here's an article that came out 2023, where one of the things that in their review, they've created a word map of studies that have engaged in One Health, and these are the terms and words that are coming out as prominent. So you're seeing things there, clearly One Health, animals, collaboration, human health, veterinary health, zoonoses, multidiscipline environment. Not seeing pollution or toxicants present in here, but nonetheless, many of the things that would be appropriate in the context of pollutants and toxicants are recognized and relevant here. So clearly, a common understanding of this One Health concept is involving multiple disciplines and professionals, and recognizing that that One Health is about human, animal health, and also ecosystem health, and all of those need to be addressed in a common integrated fashion. But what about the global One Health approach and environmental pollutants? Do environmental pollutants fall within this kind of One Health approach? Would the management of pollutants in the environment be well served by a global One Health approach? And so things we need to consider when taking this decision is, well, what is is a particular pollutant a global pollutant? Is the environment contaminated in both the human environment and natural ecosystems? Are their exposure pathways common? Do they have some impact on health that's of concern? What is the interaction between the pollutant and humans and wild and domesticated animals? And will the application of global One Health approaches be beneficial in terms of the management of that environmental pollutant? So we take a look at plastics, and so clearly plastics are a global issue. There's global contamination. It's recognized as one of the prominent global environmental issues that exists in the world today. A lot of attention has been focused on this in essentially all countries, and a lot of this started because of recognition presence of macroplastic particles in marine environments, on the beaches, on the surface of the sea, and numerous images that we've been exposed to for many years of prominent charismatic marine organisms that are entangled in plastics, whether it's plastic nets, like in this plastic net around this seal, or in whales that are entangled in it, to other organisms that have pieces of plastic particles that strangle or incapacitate them. So very evocative images that have affected the public perception and the public engagement and relationship with the issue of plastics. More recently, there's been considerable recognition of the human ecosystems, our indoor ecosystems that are contaminated by plastic particles. These plastic particles, particularly dust particles from textiles, fibers, and these types of plastic materials that are present in our everyday lives. It's staggering the amount of plastic. So plastic particles that are deliberately put in different products for their specific properties, toothpaste and washes that have had microbeads in them, plastic bottles, 1 million plastic bottles produced each minute, billions of plastic bags used each week, all of the plastic fibers that are being released during washing, and then the three big users of plastics: construction, agriculture, and transportation industries. 430 million tons of plastic produced in 2023, and it's estimated that 7,500 million tons of plastic have been produced since industrial production of plastics began in the 1950s. Clearly, this is a waste management issue. So as a waste management issue, our local policies of waste management in every corner of the world have global implications. So no matter how well we manage the plastic waste issue in one location, if it's not managed globally, the implications are going to be severe. Plastic particles are another category. So we have our macroplastic materials present in the environment. We see them; they create a certain image and have a certain interaction with organisms and effects. But plastic particles are another category, and so it's been recognized microplastic particles, large ones 1 to 5 millimeters, or small ones from 1 micron to 1 millimeters. And then also the presence of nanoplastics is now recognized in the environment. Plastic particles smaller than 1 micron. These particles can be primary; they're produced as particles, or they can be secondary as fragments. There's many different shapes and sizes, and there's a variety of different polymer types. And so the plastic particles, of course, come from releases into the environment. So these can be from wastewaters, from the transport of waste, including plastic waste, from one location to another, the storage of plastic in landfills and being released from those locations, to even the wearing of tires and the release of particles of tires onto the roadbed that then wash into surface waters. And when plastics enter freshwater systems and pass through the freshwater environment, ultimately into the sea, the plastic materials will, depending on their physical chemistry, they will either reside on the surface for some time, or they'll be within the water column. They may sink or be resuspended depending on their density. And there is evidence of plastics in all of these locations, including the accumulation of some types of plastics in the seabed of the deep sea. And with this 430 million tons of plastic produced each year, countries differ in their management of waste. And Jambeck in 2015 identified countries that have particularly large amounts of plastic waste that are available to enter the ocean, and recognize some of the countries that have particularly large amounts that may be entering into the sea. About 0.5% of the plastics produced each year are released into the ocean, it's estimated, and some countries have larger estimates of plastic emissions into the sea than others, as indicated here in a 2021 survey. And once they get into the oceans, the plastic particles can have local effects, accumulate locally on beaches in the local environment, but also can be transported globally. And among the places where they reside are within the gyres of the large oceans. And indeed, there's been accumulations of plastics detected in each of these large gyres in the sea, where quite large numbers of plastics have been found to accumulate. Clearly, it's a global environmental issue. Global engagement is needed to manage this. We have waste policy management policies in one location that manage plastics very well, but not in others. The issue of plastic contamination will continue to be a major problem, global issue. And for a global One Health approach for plastic particle management certainly is becoming recognized as important within the literature. So this is a study that came out by Prata et al. In 2021, identifying that the One Health approach and the important elements of One Health for plastic particle management in the environment, recognizing the number of disciplines and professionals that are needed, veterinarians, biologists, engineers, but also politicians and chemists and agronomists that need to play a part. And this was interesting. They also recognize designers, so designers of packaging, designers of textiles, and how all of these different professionals have a role to play within the global management of the plastics plastics issue. And so what about other pollutants? So are there examples of other pollutants where a global One Health approach is being used or considered to be used for environmental pollutions? And a couple of good examples come to mind. Polybrominated diphenyl ethers, PBDEs, are one example. Mercury, the One Health Mercury Climate Change Nexus has been recognized recently. And for both of these examples, there's global contamination of human and natural ecosystems. There's a common exposure pathways for humans and other organisms, potential for the bioaccumulation of these substances in organisms, the transfer of the substances between trophic levels within different organisms, and direct interface of these pollutants with human, wild, and domesticated animals. And these management certainly can be addressed and should be addressed by a global One Health approach. But what about plastic particles? So do plastic particles fall into this? Indeed, they do. Plastic particles do have some of the same types of situations that would be benefited by a global One Health approach, but there are some differences, and it is important that we recognize the differences as we consider a One Health approach for management. And so if we consider this, differences compared to other pollutants, so particles don't behave like traditional substances in terms of their environmental fate and toxicology. There are other things that we need to consider in that context. They have differences in their environmental persistence, their transport, and how they interact with organisms. They don't have typical behavior of dissolved substances or substances that sorb with surfaces of organisms. The important aspects of toxicology that we consider with substances, sorption, distribution, metabolism, and excretion, appear to be different with plastic particles. But one of the things that is also unique is the public perception of plastics in the environment, how important they are, and that is different than other substances. Plastics are visible within the environment, they're visible contaminants of the environment, and so it leads to a ready communication about plastics that is recognized by the public, and this can lead to misconceptions, and these misconceptions can impact our ability to manage the environmental issue of plastic particles. So what are some of the questions about plastic particles? Are they ingested? Are they absorbed and accumulated internally? What is the evidence showing? Is there transfer in the food web leading to human exposure? Are there substances sorbed to plastic particles? That is, substances, perhaps toxic substances, sticking to the plastic particles? And are these sorbed substances then bioavailable in organisms? Are plastic particles themselves toxic? So we've been working on this topic of plastic particles and how they behave for quite a few years now. One of the early experiments that we did was to investigate simply whether microplastic particles would be ingested and then egested from a very common marine organism. This is the shore crab, Carcinus manus, and this was a very simple experiment. It was conducted by an undergraduate student when I was at the University of Plymouth, and his name was Joseph Hatfield. And what he did was to make some feed pellets using some fish paste, and then he took microplastic particles and he counted them, and he put them into a pellet with the fish paste, and then he gave the crabs one of these pellets that had the quantified number of microplastic particles in it, and he allowed the crab to eat that that pellet and then fed the crab essentially clean pellets without microplastic particles in the succeeding days, and collected the feces every 24 hours and counted the number of plastic particles that he found. What the results were quite interesting. So first of all of the microplastic particles were found in the feces within 3 days. He also made some feed pellets that had similar sized sand particles. So this is a silica sand, same size as the microplastic particles, 2 sizes that he was testing, and he found that the microplastic particles stayed just a few hours longer than the sand particles in this bit. But all of them were released, so they weren't accumulating internally; they were passing through the gut and being egested. Not too surprising when you think about it, because crab lives in an environment where it's exposed to numerous particles such as sand and natural particles, which are in enormous numbers in the environment, particularly in the environment in which a crab lives, where it is ingesting bits of sediment, bits of sand. And so you would expect that the organism would be pretty good at passing these particles through its digestive system and not accumulating them internally. So it's perhaps not too surprising that plastic particles are not being absorbed and accumulating within the internal tissues. But what about nanoplastics? So we as we progressed and became more sophisticated in our examinations, one of the challenges with investigating plastic particles and plastic particle exposure is detecting them in tissues. So the traditional methods of tissue extraction of substances for detection of concentrations aren't suitable for plastic particles. So new methods have been required to permit these types of investigations. And one of the things that we did, my postdoc, Maya Al-Sid-Sheikh, she prepared some 14C labeled nanopolystyrene particles. So these were particles from 20 nanometers to 250 nanometers in size. And then she conducted some experiments where these particles were added to feed of rainbow trout. The trout fed these feed pellets, and you can see the nanoplastic particles remained within the digestive tract of the fish, with very, very minimal absorption into other tissues, and certainly not accumulation in internal tissues. What about the topic of absorption of toxicants and whether those substances are bioavailable? So indeed, plastic particles, plastics, in the sense when plastics are manufactured, there are numerous substances that may be added to the polymer mixture of the plastic to confer specific properties to that plastic material. And those substances can have their own toxicological concerns that need to be addressed. And substances, so in plastic particles, for example, that are present in the environment, they will interact with substances that are present, toxic substances, and those substances can become sorbed. I like to think about it as an equilibrium equation, chemical equilibrium equation. Quite simply, a microplastic particle plus a toxic substance is in some equilibrium, where with the substance sorbing to the surface and desorbing depending on the relative concentrations and the physical chemistry of both the toxicant and the surface of the plastic particle. One thing to recognize is that the presence of certainly toxicants are sorbed to microplastics. So if you go out in the environment, numerous studies have documented the presence of numerous types of substances associated with plastics. But the presence of a toxicant associated with a plastic doesn't mean it's bioavailable. Doesn't mean that if an organism ingests that microplastic particle, that the associated substance will be released and lead to some toxicity in the organism. We have found, mostly with fish models, that sorption of various types of substances sorb to microplastic particles in the aqueous phase. This is influenced by their physical chemistry, but not completely predicted by it. There's indicating that it's more complex, the process of sorption and how substances interact with plastics is a complex process. But the delivery of toxicants to organisms appears to be minimal in most of the experiments that we have done. That is, the taking a microplastic particle with sorbed toxicant and then administering it to an organism does not lead to automatically to bioavailability of that substance. And indeed, in some situations, microplastics can reduce toxicant bioavailability. So an example of that is in experiments that we did with benzoate pyrene, investigating the sorption of benzoate pyrene to plastic particles. And so looking at the bioavailability, so let me just orient you with this figure for a moment. On the x-axis is the concentration of benzoate pyrene, increasing from left to right. And on the y-axis is our measure of bioavailability. And this bioavailability measurement was the change in gene expression, the CYP1A gene, which has this gene increases in expression. It's an indication of greater bioavailability of benzoate pyrene. So if the benzoate pyrene is present just in the water, it's highly bioavailable. So the benzoate pyrene sorbs to the fish and is absorbed quite readily, and this leads to induction of the CYP1A gene. Sediment is included in that system. It appears that the bioavailability of the BAP is reduced because the benzoate pyrene sorbs to some of the sediment particles and is not bioavailable to the fish in that situation. Then if we further add some 1 micron size plastic particles, the bioavailability is reduced further, which suggests that the benzoate pyrene is also sorbing to those plastic particles and becoming less bioavailable in that particular situation. So let's consider some of the misconceptions that I alluded to earlier. One of them that has become prominent is the misconception around plastic particle exposure from the ingestion of seafood and the risk to human health. So we published this article at the end of last year to try to examine the evidence around this particular topic. It's an interesting story because there is this public perception about seafood contamination by plastic particles, and this has been shaped by the media communication, in some cases rather than scientific evidence. And these perceptions have informed behavior and public policy at times inappropriately. And so there is certainly the public perception that seafoods are a prominent source of plastic particle exposure, and that plastic particles consistently raised as among the greatest concern of consumers of seafood. And so there's the respondents of surveys in the UK and China indicate that their decision about consumption of seafoods is impacted by their concern for plastic particles, and they are consuming less seafood as a consequence of their concern of plastic particle exposure. But why is there this perception? Why is it that the public has gotten this conception, which we offer as a misconception about the risk to exposure from seafood and plastic particles? And some of this may be because of the presence of plastics in the environment and the recognition of marine environments as having plastic particles and plastics in them. These images of marine organisms that are entangled in fishing nets and other macroplastic particles, macroplastic materials, and this creating a situation that makes that is very evocative in the public, and the story of plastic particles is an easy connection to make between seafoods and consumption. And so many of the early studies focused on seafood, and that led to even further engagement with seafood. And in our article at the end of last year, we reviewed the literature and recognized that the number of articles that have assessed the plastic particle exposure from seafoods is more than 70% of all of the other studies combined, in terms of the focus and the scientific effort that has gone into assessing the contamination of seafoods by plastic particles compared to other sources of exposure. And so quite a lot of focus on seafood, and that evolved from perception that seafood were of greater risk, and perhaps also because seafood was something that was perhaps a bit more accessible for investigation. But this topic is something that needs to have some evidence behind it. So what is this? What is the evidence about seafood contamination by plastic particles? We were doing a study in Scotland. I had a postdoc, Anna Katerina, who was going around the coast of Scotland and collecting mussels from different locations, bringing them back into the lab and assessing the plastic particle concentration that were present in the mussel tissues. Mussels, of course, are an attractive organism for this because they filter large quantities of water. And as such, it's a reasonable hypothesis to think that they would filter out and thereby be exposed to large numbers of plastic particles. And perhaps those plastic particles could then be transferred to humans. But what she found was that the amount of plastic particles that were present in the mussels was quite minimal. And in fact, putting that into context, she assessed the plastic particles that you would be exposed to as how many plastic particles would fall on a plate of mussels in a typical household during the preparation of the meal and eating of the meal. And she found that there were orders of magnitude higher number of plastic particles that were falling onto the plate than were in the mussels themselves. So further considering what the evidence is showing, European Food Safety Authority has estimated the median ingestion of microplastics by shellfish at 1 to 10 particles per adult per day, which is about what we found in what Anna found in her study of mussels on the coast of Scotland. Plastic particle ingestion via water consumption, 10 to 100 microplastic particles per adult per day, has been reported in a number of studies. Other sources of exposure are being investigated more and more. These things are being considered, and plastic particles are being found in all of these: salt, honey, sugar, beer, milk, and these are reporting to give exposures of around 10 particles per adult per day. It appears that processed foods may have higher levels of plastic particles than unprocessed foods, perhaps because of plastic particle contamination during the processing of the food materials. But the air exposure appears to be the major source of plastic particle exposure by orders of magnitude. And so this conception of seafood being a major and prominent source of plastic particle to humans is not supported by the evidence. So this topic, and I just use this as one example about the topic of seafood and the misconceptions that exist around the exposure of humans to seafood and plastic particles. We're addressing numerous other perceptions and challenging perceptions that exist about plastic particles exposure that exist in also in the context of how the topic has been presented both in the scientific media and in the public media. And in this book, each chapter is addressing a specific misconception with a critical review to try to say, well, this is actually what the evidence is showing. This is not to say that plastics are not an environmental issue. They are a prominent and very important environmental issue that we are challenged to address. The Global One Health approach for addressing this is certainly very appropriate. But there are things that we need to be conscious of in terms of misconceptions, and we need to work very hard to avoid what those misconceptions are. So definitely just concluding remarks here at the end of my 30-minute time slot. Application of the Global One Health approach is certainly appropriate for addressing environmental issues of plastic particles, and the addressing this issue requires the multidisciplines to engage, but importantly, recognize the misconceptions, follow the evidence, and proceed in that way. Okay, thank you very much.